It's really overdue. It is time for me to talk about the OM1 and the sensor in this camera, what I think about it, all the information that I've been able to dig up about it, and I have dug up quite a bit. And I've experimented a lot and done everything else that I can think of to test this thing. And yes, I found some pretty cool things. And I'm going to analyze it as an astrophotographer would. What sensor is in this camera? This is actually a very easy logical deduction. Even though Olympus has not publicly told us what sensor is in this, we can look at the spec sheet on Sony's website and pretty much conclude 100% surety here that it's the IMX472. Alright, a little bit of history here. So, in the past, Olympus has almost always purchase an exclusivity contract for a sensor that they've used in their flagship cameras. OM1, first time this hasn't happened. Now, what does exclusivity give you or do? Well, let's go back and look at the IMX270, which was used in the EM1 Mark II, also the EM1 Mark III, the EM1X, and the EM5 now Mark III. So yeah, they've gotten their fair share of use out of this sensor. But anyways, exclusive contracts usually give you access to technologies that can be packed into a sensor that, you know, are quite advanced and quite cutting edge. What this also means is that the cost obviously goes up and you're tied to buying that sensor. You have to buy that sensor for a certain number of years. There's different ways you can write the contract. You may have to just buy a huge quantity up front, like, I don't know, so many millions of sensors or whatever. What this means for the IMX472, which is in this guy here, is that Olympus isn't tied to this sensor. I mean, this sensor came out and was available for sale before the OM1 was launched, almost a year before it was launched. That means Olympus could tomorrow get a new sensor, okay? They could use a different sensor in the next camera that comes out. And I think this is great. It means that Olympus is saving more money, it's costing them less, which is kind of one of the reasons why the OM1 was actually a price cut. I know the price went up in dollars, but if you take inflation into account, which is ridiculous right now, it's actually quite a bit less than the last two cameras that they came out with, the EM1 Mark II and the EM1 Mark III in this line. And also, it means that, you know, we're not tied to the sensor. This isn't the sensor that we could see for the next 5 years. You know, some people have been moaning. It's like, oh no, this is the sensor we've got to use for the next 5 or 6 years. Relax, guys. Tomorrow, Olympus could get a new sensor. We don't know, because there is a lot of cool things coming out in the sensor world. We've got great things to look forward to in the future. Now, that's not to say that I am not in any way dissatisfied with the sensor's performance of this camera. This camera sensor is quite a bit. Alright, so let's talk about the megapixel count. And surprisingly, this is the only thing that anyone has ever complained about, which, if you did any research prior to the launch of the OM1, you would think that this would have not been something that people complained about. The megapixel count, okay, the megapixel count, it's exactly the same. And this is the first time ever that Olympus has gone from one sensor to another and has not increased the megapixel count. Now, if we went back to 2019 and 2020 and even 2021, every place that you looked where people discussed the new sensor that might be into the next Olympus camera, everyone overwhelmingly said they didn't want to see a megapixel count increase. As a matter of fact, one forum even did a small survey, and only 2% of those people that were surveyed said that they wanted an increase in the megapixel count. And Olympus themselves even said that they did a lot of research, and overwhelmingly, people did not want to see a megapixel increase, because 20 megapixels is quite plenty. 4/3 rumors, okay, they did a survey, and in it, the only option you had was to select a sensor that had a higher megapixel count. And a lot of people commented below saying that they didn't like the fact that they had no option to select the same number of megapixels, just better ISO performance. Which, I'm an astrophotographer, as you can probably kind of see by all my junk. I do mainly astrophotography, and in astrophotography, we like big, chunky pixels. We don't like small pixels. So the fact that the new camera is the same number of megapixels, I was overjoyed about this, okay? Send me hate mail later. But yeah, so it's the same 20 megapixels. Now, interestingly enough though, each pixel, it's a quad Bayer sensor. And that means that each pixel is actually made up of 4 sections. Whether or not those can be unbinned, essentially, and turned into the 80 megapixels that it actually is, because there really are 80 megapixels making up the sensor. It's just there's been some debate as to whether or not this is a hardware locked-in type system. I know, for example, the Sony A7, which I think is a 24 megapixel sensor, that sensor was hardware binned. Okay, you could not unlock it. Same thing with the Panasonic GH5S. Okay, that 12 megapixel sensor, which is also found in the ZWO 292, that is a hardware binned 44 megapixel camera that is binned down to about 11 megapixels. So it's a binned sensor. It sort of is more megapixels, but it isn't. So yeah, we kind of really did get both, okay? And I like the fact that it's still 20 megapixels because that's plenty, especially for my skies. All right, let's talk about backside illumination, how it is affecting the new sensor versus the older guys. Now, the EM1 Mark 1 here was not a backside illuminated sensor. Neither was the last generation, the EM1 Mark 2 and the EM1 Mark 3 and the EM1X, etc. and so forth. But the EM1 Mark 1, it had a Panasonic sensor, and it was kind of a revolutionary sensor in its time because it was the first camera that really used big micro lenses that focused a lot of the light onto the pixel and actually through the wiring that ran across the top of the sensor. Now, this, of course, created a microlensing issue though because they weren't very well coated and so forth. Now, fast forward to the 270 here, the IMX270 Sony sensor that is in the EM1 Mark 2 and the EM1 Mark 3. This guy was quite an improvement. We went from 60% quantum efficiency of the older sensor to almost 80%. By my calculations, it's 78%. Some guys are saying 80, 81. That could be a rounding issue and how they're calculating it, I don't know. But anyways, so quantum efficiency in this guy was really no slouch, and there actually wasn't a lot of room to improve it here. Now, forwarding on to this guy is now backside illuminated, which means that all that wiring that the micro lenses had to basically focus in between isn't there anymore. Okay, so the silica is much closer to the micro lens, and we pick up even more light now. Now, by my estimations, it's around 90-91% quantum efficiency with this guy. But there's a little improvement here that we've seen, okay? And that is light that is focused on an angle on the pixels. With the older guys, even though this guy had a good quantum efficiency, this EM1 Mark 3 here, the light, because if it came in at an angle, all right, it would have to go through all that wiring, and a lot of times at an angle, it would hit that wiring and it would reduce the amount of light hitting the silica, which meant that vignetting with wider lenses was significantly greater. And this is something that has been an issue for a lot of sensors for many, many years, all the way back to the E1. And Olympus was the first company, by the way, that pioneered software that actually brightened up the edges to compensate for vignetting based on the lens that was put on the camera, okay? And I did a test, though, to see how the backside illumination here changes this, and it's really surprising, the result. I went out and I did some flats, basically some sky flats using the 17mm f1.2 here. We used the exact same shutter speed between the two cameras, same aperture, same ISO, it was ISO 200. We used all the same color settings and so forth, and you won't believe this, but the vignetting in the traditional camera here, the EM1 Mark III, is 15%, all right, with this 17mm f1.2 lens. With the OM1, it's only 3%. That's a 5x improvement. So for wider lenses, okay, you're not going to see as much vignetting as you have in the past. And this is kind of something that, yes, sensors are just going to get better in almost every respect. And it's really cool that there was that much of an improvement there. I was really not surprised that the improvement was that much. Now, lenses that are longer focal lengths like this 40 to f150, not going to see as much improvement with something like this because the light is directed more straight towards the sensor. But, you know, still, it's pretty cool. All right, so you're probably wondering to yourself, why haven't they always been doing backside illuminated sensors? Well, the fact of the matter is, backside illuminated sensors are hard to make, okay? And we've only just been able to start like getting them into a lot of cameras because now we've got the technology to do it. Now, I want you to imagine, if you will, this was a wafer, okay? That's what sensors are made on. They're made on silica wafers, and they actually have these transparencies that they put over them that have all these holes and cuts through them that allow them to basically eat away at certain sections of the wafer, creating the circuitry necessary to create all the computing necessary for a sensor to work. And doing a backside illuminated sensor means you have to flip this thing over a couple of times. And that's not easy, because flipping it over, it's got to stay exactly flat. You can't touch this thing in the middle here. You know, you can only support it on the outside edges. And so the engineering challenges that were involved with that were kind of considerable. And it took them a while to solve this, but now just about everybody can do it now. And you're seeing it in pretty much every sensor these days. Everybody's going to be backside illuminated. Next, the byte depth. So the bit depth of this sensor, the new OM1, it's the same as the older one. It's 12 bits, right? However, that number being the same isn't necessarily true, okay? So just because you take a picture with a sensor that spits out a 12-bit file doesn't necessarily mean that it's actually 12 bits of data. Classic example, my Olympus E1s from yesteryear, okay? Those things, that camera spit out a 16-bit file. It doesn't create 16 bits worth of information, okay? They were basically rounding it up to an integer that most computer programs could work with easily, right? And the same thing goes for these guys. Now, the EM1 Mark III here, actually this is the EM1 Mark II, down here is my EM1 Mark III. When I was doing my flats test to basically test the vignetting of the sensor, the files that were coming off the camera were 8 bits, basically, at those particular ISOs and so forth. The OM1 here, it was producing a 9-bit file, which means that it has more data, which also means that it has more dynamic range. So I know some of the reviewers out there have said, DP Review in particular, have said that they have seen no improvement in ISO performance and no improvement in dynamic range. And I gotta say, I don't see how they do that conclusion, because every single way that I can test the sensor, it is better in ISO performance and it is better in dynamic range. Yeah, did they use the wrong camera when they did the test? I don't know. But, you know, I've definitely seen an improvement. Now, here's something else. So, the older IMX270 sensor had 2 different ADCs, or amplifiers, on the sensor. And the second one that would kick in was at ISO 2000. And that one was pretty sweet because it gave you a fairly low read noise. And also, you know, you got, you know, nice dynamic range, okay? Still not great because you're all the way up to ISO 2000, but still, it's pretty good. So, with the older IMX 270 censored cameras that I have, I typically use ISO 2000 or ISO 400. It kind of depends on the target. With the new OM1 here, this guy now has actually 3 different ADCs for each pixels, which means that there are 3 different points where the noise is actually going to change significantly, or at least read noise. And this guy, its new sweet spot, when we call this unity gain, by the way, so unity gain for the older IMX 270 sensors, ISO 2000. This guy is ISO 1000. So on this metric alone, for astrophotography, for me as an astrophotographer, you can expect to see a one-stop improvement on this metric alone. One-stop improvement. And that is because, well, obviously at ISO 1000 you have more dynamic range, but we have the exact same amount of read noise as the older guy did. And in astrophotography, the majority of the detail on our photos is in the shadows anyways, because we stretch our stuff after we stack it, so it's kind of different for us compared to the daytime guys. Now, as for the read noise, okay, I've looked at photons to photos, their charts and so forth, and theirs were a little bit off from what I was getting. I was actually able to get about a 10% lower read noise rating at pretty much every single ISO that I tried relative to their numbers. So I know they showed it to be pretty much the same, but in my tests, read noise is in fact lower with this guy, which is great. You know, it's about 0.1 electrons per photon of light lower than the older OM1s, EM1 Mark III, 2, 3, so forth. Man, all these names, it's a tongue twister. So the backside illumination sensor aspect of the sensor has received a ton of press and a lot of people have talked about it. So I'm going to leave that topic. Now, one thing that has reduced noise in this sensor that nobody has talked about is actually this, the SLVS-EC, which is a new, it's a new system that basically adds additional channels to the sensor. Now, why is this important? So traditionally with the IMX270 sensor, you had your sensor here, okay, and the actual ADCs that convert the signal coming off of the silica from analog into digital were usually housed on the edge or off the edge of the chip. And that meant that there were these highways, if you will, that information would travel across the sensor. And some of these, now the pixels that are right here obviously are a lot closer than the pixels that are way over here. And what this meant is that pixels that were really close, they actually had to kind of like spool the wire, so to speak, before it actually went off to the ADC. That way the wires would all be the same length and they would potentially pick up the same signal, okay? Now, having these long wires, of course, and sending the signal this far meant that there were a lot of opportunities for it to pick up interference because it's still an analog signal. Now, the SLVS-EC system actually has the analog to digital converter built right underneath each and every single individual pixel. So when the signal comes off, it immediately gets turned into a digital signal and then it's sent off the sensor. And this is one of the reasons why a lot of you have noticed that there's less banding in this particular sensor. It's because of the SLVS-EC system. I know, terrible marketing name, but it works. For the second last test that I did with this camera, I basically did a dark current measurement, okay? Now, dark current, I'm going to clarify to you what this means. Dark current is basically how sensitive the sensor is to heat, okay? Because not all sensors pick up heat the same way. Even if their pixels are the same size and all of their other characteristics are the same, one sensor may not pick it up as much as the others do. And the newer sensors, by the way, tend to be more immune to dark current. Also, smaller pixels are by nature more immune to dark current. This test was fairly simple. It's done with the lens cap on the camera. Basically, we are looking for a long exposure. These were 1 minute exposures and they were done at the same ISO, of course, and all other settings were set the same, things like color balance, white balance, etc. and so forth. And I tested temperatures between 25 degrees Celsius and 30 degrees Celsius. And of course, lo and behold, the OM1 is less sensitive to dark current, which means that it's about 4 degrees ahead of the EM1 Mark IIIs is kind of what I was able to determine from what I tested. Sometimes it was about 5 degrees. It depended. It was right on the edge there. Now, the interesting thing though is that even though it had less noise thermally, that thermal noise was vastly more consistent in the OM1, which means that it's going to calibrate out better when you take dark frames, and that's great news, okay, because it means that calibrating for your OM1 will be easier and you'll be able to get a better astrophoto. Now, the last test that I did was actually just to go out and take a picture, okay, which was actually a little frustrating because we've had about 3 months of rain here. But we were down in Florida for a little while, so I did get some clear skies and I photographed a few things, some star trails and some single shots. And I must say that stars in this thing appear to be much smaller. And I will lastly comment on like daytime photography. So in daytime photography, with the older cameras, I typically kind of called it quits at ISO 3200. That's about the noise that I was willing to tolerate. With this guy, I easily find myself accepting 6400. Okay, so there. From a daytime perspective, I feel like I have gained one good stop of light performance with the new sensor. And I know DP Review said that they didn't see any improvement, but like I said, I don't know why they saw no improvement, because every single way that I dice this thing, I see improvements. I see improvements in almost every single aspect of the image. Dynamic range is better, stars are smaller, which means the pictures will look sharper. Noise is less, it's more consistent, there's no banding, the vignette is less of an issue. It's 5 times less vignette with wide angle lenses in this camera, which is cool. Okay, that's that's actually a really unexpected improvement for most of you, I'm sure. But I'm going to stop talking about the OM1 now. I've got other things that I'm going to start talking about in the channel. But here, let me tell you though about a few things that you can kind of expect of this sensor. So this sensor really, it's hardly being scratched, okay, as far as its capabilities goes. Its capabilities are way beyond the rest of the hardware in this camera. There are actually scientific camera companies out there who are already putting this IMX4782 sensor into cameras, and they're getting 4K, actually 5.7K at 120 frames per second. So yes, the sensor in this guy is capable of doing that. Whether or not the processor in this thing can do it is kind of another question, and that may be the reasons for the limit at 4K 60 frames per second, but who knows? Maybe a firmware update could change that, I don't know. But like I said, the sensor in this thing is way beyond the capabilities of the hardware of this camera so far. So we have a lot to look forward to, and even if Olympus doesn't switch to another sensor around the corner, there is a lot of room to improve this thing through either software or maybe even by doing an OM1X with 2 of these processors in there. That would be pretty cool. I know I have actually only bought one OM1 because I'm kind of saving my money in case Olympus does come out with an OM1X, because if they do, I'm buying that right away. So hope you enjoyed this, and now I need to go play with the new telescope, so I'll see you around.